One of our major theorems in calculus is called the intermediate value theorem. And any calculus class that you take if in college will probably include a lot of theorems. So this is the first one. I want you to be able to look at these theorems and try to understand it. We are going to go through this like one part at a time, and I'm also going to draw a picture. I think it'll make a lot more sense if we have a picture. So here's the first part. If f is continuous on a closed interval ab, so when you have an interval, by the way, those are x values. So we're going to have a function that is continuous on ab. I'm just going to draw a random function. So it doesn't necessarily start and end at ab, but it's continuous over that interval. Okay, so that's the first part of it. So the next thing they say is k is any number between f of a and f of b. So f of a is going to be whatever your y value is when x is a. F of b is going to be whatever your y value is when x equals b. So they told us that k is a number between f of a and f of b. So I'm just going to put k here. Then the last part is that there is at least one number c in this interval ab such that f of c equals k. So f of c equals k, that's going to be right here. So actually the c value that we have is right here. You'll notice it's somewhere between a and b. So go ahead, write this down. I recommend that you draw a picture if the picture helps you. And if you need to pause for a minute or two to try to understand it, go ahead. And then we're going to do an example. So our intermediate value theorem example is right here. By the way, I put the theorem at the top because we're going to refer back to it. So when it says that there is a root of the given equation, basically what that means is they're saying that if f of x was equal to this thing right here, then there would be a value where f of x is equal to 0. So you have a few problems like this in your homework. Just keep in mind that this is what it is asking you to do. So the way that we're going to figure this out, first of all, you need to check and make sure that this is true and then this is true. So whenever you have a theorem, you always need to start by checking the if statements, and then you can come to the conclusion of the then statements. So first of all, we're going to check the first thing. This function is continuous. We know that because there's no crazy domain issues, there's no fractions, there's no square roots, so it's continuous on this interval right here, 1, 2. The second thing is that they want to know if k is a number between f of a and f of b. So notice that our a value here is 1, our b value here is 2. So f of a is going to be our f of 1, our f of b is going to be f of 2. In this case, k is 0. So it's going to be whatever y value or whatever f value you're looking for. So we want to know if that's true. So, okay, so let's look at this. So f of 1, if you substitute 1 into the function that we have right here, you hopefully should get -1. Do the same thing with f of 2. And hopefully when you do that, you should get 12. So basically all you need to do now is you need to check and see that 0 is between these two values, and it is. So our first thing is that we did was check continuity. The second thing is checking that 0 is between those two things. So I'll usually write something along the lines of, since f of 1 is equal to -1 is less than or equal to 0, is less than or equal to f of 2 equals 12. We're good on all of those. We can use the intermediate value theorem, and any calculus teacher, any AP grader knows that IVT in calculus means the intermediate value theorem, so you can feel free to abbreviate. So we use the IVT, we use the intermediate value theorem, and so now that's where we can look at that then. So this says then there is at least one number C in AB such that f of C equals K. So I'm going to rewrite that in terms of the numbers that we have here. So I'm going to say there is at least, we don't know what the C is, by the way. We're not going to bother trying to find it. It's a lot of work. Such that I'm going to write ST as an abbreviation. Sorry, it should be at least one C in 1, 2, such that f of C is equal to 0. So that's actually because K is equal to 0. So since we know this is true, we use the intermediate value theorem. Therefore, and you can actually just repeat what I wrote just up there. Or you can also repeat what they asked you to find in the question. So I just wrote, therefore there is at least one root in 1, 2.